Okay, so I've shared the screen here. So these are all going to be equations that are exponential functions. And we talked the other day about what an exponential model looks like. So let's just write that down. All tangled up here. Okay, so an exponential model, we said, was always in the form y equals a b to the power x, where y is the end amount and a is the starting amount. So we always take an initial amount, we multiply it by a common ratio, so that would be your b, and then you do that a certain number of times, which is your x. Okay, so they're all the same model. Okay, so in this question, John has a bank account with a balance of $100, so that's his start amount. He earns 4% per year. So this is my common ratio. So remember, if we are given as a percent, we always start with 100%, and we either go up or down. So this one's increasing. So it'll be 104%, or as a decimal, 1.04. And then it wants to know how much money will he have after 12 years. So my equation, I might use A for amount, or I could use Y, doesn't really matter. My starting amount is 100 times my common ratio, and I want to do that over 12 years, which is my time. So we just put that into the calculator. Remember that you want to do your exponent first, so we would type in 1.04 to the power 12 first, and then multiply that by 100, and you'll end up with $160.10. So that's the amount he has after 12 years. Okay. All right, the second part of the question says, how long will it take for his bank account to grow to $136? Okay, so if I'm looking at my equation, now I have an end amount. So I'm going to put in the 136.85 in the end amount. He still started with $100. It is increasing by 4%, so my common ratio stays the same, and this time I'm looking for t, the time. So we want to solve for t. You cannot multiply these two numbers together. And the reason you can't do that is because the 1.04 has an exponent attached to it. So that exponent belongs to the 1.04. So that number in that bracket is not really 1.04. It's 1.04 to a power. So the only way it's actually equal to 1.04 is if t is 1, right? Because 1.04 to the power 1 gives me the same number. Other than that, it doesn't equal 1.04. So we cannot multiply those together, although I see it all the time. People do it. That's not how we're going to solve. So we need to get rid of the 100. The 100 is multiplied, so we're going to divide. And then we'll do the same to the other side. Okay, so now we have 1.3685 to that. So I have to solve for t. You are going to estimate. If you were in the MAP4C, the other course, we would use logs. But in this course, we do not work with logs. Logs are the inverse of exponential functions, so they kind of undo them. But in this course, it's not a required topic, so we're just going to estimate. So how do we estimate? Well, we need a calculator. So we're just going to start. The question I'm asking is 1.04 to what power gives me an answer of 1.3685? So I'm going to start with 1. Well, 1.04 to the power 1 is 1.04. Then I might try 2. So I'll just type that into my calculator. Well, that's not even close. So I'm going to skip over to 10. Right? You could put in whatever number you want. So I'm going to skip over to 10. 1.04 to the power 10 is 1.480. Well, that's a little bit too big, right? Because I want to be getting an answer of 1.36. So 1.48 is a bit too big. So I know it's less than 10. So I'm going to try 8. And that gives me my answer. So it's a matter of estimating. You're going to try different numbers. You're just going to type them into the calculator, and you're going to get the power that gets you closest to the answer. So my answer is 8 years. Okay? 1.04 to the power 8 is the final answer. So my solution would be the exponent 8. So t is 8 years. Okay? So you just have to get good at estimating. All right, let's try another one. Okay, that's not the one I wanted. Let's do this one. Okay, so number 2. Population is given. They give us the equation. So the population, the starting population is 6,191. Common ratio is 1.03. Well, what does that tell me? 1.03 means 100. Oh, the smartboard's been acting up today. So this number here means 103%. Right, this actually means 103%, if I can get this thing to work properly. So it means it's increasing by 3%, right? That's what that means. So I have a starting population of 6,191. It's increasing by 3%. How many years will it take the population to grow to 10,000 people? So my end population needs to be 10,000. And then we need to solve for t. So as in the previous question, we cannot multiply 6191 by 1.03. We need to divide to get rid of that. And then we're going to divide on the other side. So that division gives us a number 1.6152. So again, we now have to estimate. So we want to estimate 1.03 to what power gives me 1.6152. So if let's say I did to the power 2, I get 1.0609. Well, that's way too small. So maybe I'll skip over to 10. So I'll just type it into the calculator, and I get 1.3439. That's closer, but still not big enough, right? Because I have to get 1.61. So I'm going to skip over to 15. So you can use whatever numbers you want. That's 1.55, so that's closer, but still not close enough. So maybe I'll skip over to 17. That gives me too big. So maybe I'll go 16. So I just have to keep trying till I get close. So that's pretty close. I know it's between 16 and 17. 16 is a bit too small. 17 is a bit too big. If I want to go closer, I could use a decimal. I could use 16.5, and I get 1.62. So that's pretty close. Okay, so you can go as close as you want using decimals. So I'm going to say it's about 16.5. Remember that these are estimates. Right, so these are not going to give you an exact answer. It would take about 16.5 years. So I'll just say about 16.5 years. Okay, so remember that it is an estimate. So you want to get as close as you can get. Okay, this is number 3. So you have some land that was purchased for 30,000, so that's your initial value. So the initial value is 30,000. The land is increasing in value by 5%. So starting with 100%, it's going to go up by 5%. So it's 105%, or 1.05 as a decimal. How many years will it take the land to have an approximate value of 90,000? So starting population's 30,000, ending population's 90,000. Common ratio is 1.05, and we're looking for the value of t. So let's get rid of this 30,000. So that gives us 3. Okay, so now we have to estimate. We have to figure out 1.05 to what power gives us an answer close to 3. So I'm going to give you a second to see if you can figure that out. So grab a calculator and see if you can get close to 3. I don't see anybody answering my question. Okay, I skipped right to 20 because just based on the previous questions, it seemed like it needed to be a big number. So I typed in 1.05 to the power 20 and I got 2.65. So that was close, but not big enough. So then I tried 25, and that was a bit too big, right? It was a bit bigger than 3. So then I tried 23, and I got 3.07. So I thought that was pretty close. Okay, if you want to go closer, you can use a decimal, but 23 is a pretty good approximate answer. So my answer would be approximately 23 years. Was it years? Okay, so you can use your calculator to see how close you can get. Devin answered 23. Very good. Okay, we're on the same page. Okay, here we have an adult taking 400 milligrams of ibuprofen. So that's my starting amount. Every hour, it decreases by 29%. So be careful with this one because we're going down. So we're going to take our 100% and minus 29% is 71%. So don't put in the 29, right? Sometimes we want to put in the 29, but it's the 71% that's left. So it's 400. Common ratio is 0.71. How much is left after 6 hours? We can just put that in there and type that into the calculator. And we have an amount of 51.24 milligrams. Okay, so that's part A. Part B says, how long will it take to reduce the amount to 100? So end amount is 100. 400 is the start, common ratio. And this time we're looking for T. So we will isolate for T by getting rid of the 400. Which gives us 0.25. And then we have to estimate. So we're doing 0.71 to what power gives us 0.25. So I tried 3, and I got a little bit too small. It was 0.36, so that's a bit too, oh, that's a bit too big, sorry, not too small. So then I tried, because it was a decimal, right? So that 3 is actually, the bigger the number, the smaller the decimal, because my base is a number less than 1, okay? So when I do 0.71 to the power of 4, I get 0.254. So that is close to my answer of 0.25. Okay, so just keep in mind that if it's a base that is a decimal or fraction less than 1, the bigger the number, the smaller the answer. Okay, so that means it takes about 4, what is it measured in hours? 4 hours. Okay, so a lot of these questions, you just have to use that concept of estimation. Okay, what's the next one? Okay, so I'm going to get you to try this one. Okay, if you have a calculator handy or your phone, write the equation, put in the numbers that you know, and then see if you can come up with the answer. I'll give you about 2 minutes to do that. Okay, let's have a look at this one. So, same model. Let me grab my pen. I dropped my pen. Okay, so same model, y equals starting amount times common ratio, a certain number of times. Starting amount is $2,100 for the computer. We want to know when it has an end value of 600. It is decreasing by 50%. So it's going to be 100% minus 50%. So it will be valued at 50%. So 0.50. And then we just have to solve for t. So we'll get rid of the 2,100. And that gives us a value of 0.2857. So here's where we're going to estimate. So obviously power 1 gives me a number that's a bit too big. So I did power 2, and that was 0.25, which is slightly too small. So then I tried 1.8, and I got 0.287. So I think that's a pretty good estimate. And so that is my answer. Time is 1.8 years. Is this measured in years? Yes, annually. Okay, so 1.8 years. Okay, once you do a few and get the hang of it, you actually get pretty good at estimating. It's not that difficult.